Okay. I don't know if this is going to work, but we're going to try it here. I'm going to fill this big bucket with a bunch of really hot water. It's a 5-gallon pail. You can see that water's coming there. Excuse me, the steam's coming right off. Nice. Okay. Oh, yeah. Let's get that nice and centered. Nice hot bucket of water. I don't know how hot it is. Do I got a... Oh, I don't have my thermometer down here. Shoot. I'm guessing. Let me just feel this. I'm saying that's about 40 C, I'm guessing. How you doing, Shamoria? Shamori, sorry, what's going on? We're gonna drop some dry ice into this container of really hot water. And then we're gonna fiddle around with it, just for the heck of it. So I'm guessing this water is maybe like 40 Celsius. And this stuff is minus 78.5 Celsius, or negative 109 degrees Fahrenheit. I like to say this is like a bad day in Antarctica. That's about that cold. Let's pop it in there, baby. Let's pop it in there, see what happens. Oh, that's beautiful. Just pretty. Isn't that pretty? And now what I'm going to do, I'm going to back it up just a bit. I'm going to try to get a soap film over this. No, it's not fuming hydrogen oxide. I guess maybe in a sense it is. It's a little water. Here, let's try this. I got this t-shirt, strip of a t-shirt that I'm soaking in some soapy water. I'm going to try to draw that over the top. See if I can't make a soap bubble up here. Let's see. Oh, I think I'm going to need some more water. Yep, it's not enough water. We'll get this. We're going to have to work on it. Let's try this here. Oh, my hands are so slippery from the soap. Here we go. A little too much soap and not enough water. Get a little more water in there. There we go. This might do the trick. All right, let's try her again. Come on, give me a soap bubble. I think I got it. There it goes, baby. We got the bubble going on. Come on now. Come on now. Look at that. Thank you there, Matilda. When do you think it's going to pop? That's just pretty. Look at that thing, man. Here we go. I'm blowing on it. Just a little bit. Look at that. Boom! All right, let's try her again. All right, I got my little soapy t-shirt here, or that, you know, just a little string from a t-shirt. Put this over the top. Now, what's cool about this is you'll notice that my finger has, you know, some soap on it. And if it has soap, I should be able to put my finger right in there and it won't pop. You can pull it right out, too. As long as there's soap on my finger. Let me blow on it a little bit. Isn't that crazy? Oh, that's freaking cool. The negative 100, it's like negative 109.5, if I remember correctly, Kino. It's dry ice. It is pretty cool. Yep, I put dry ice in there. Boom! Down it goes. We'll try another one, just for the heck of it. So once again, as long as my finger is coated with soap, it's like Ghostbusters 4. I can put my finger right in there, take it out, nothing happens. As long as, you know, as long as my finger is coated with the same soapy film that the bubble's made of. We'll blow on it a little bit. Beautiful. I think that's beautiful. When's it gonna blow? When's it gonna blow? Pretty soon. I want to get that light shining on it just a little bit differently. Let's see if we can get that. That makes it look a little warmer. I'm going to try this. Try moving this way so you can see the shininess. Come on, clipped. Rico. Never thought I'd see watching a grown man. Oh, whatever. Hey, that one's going pretty well. Love and peace there, Reaper. That's hilarious, lady. Down it goes. Isn't that beautiful? Thank you there, Rico. Appreciate it. All right. Let's put a little bit of soap film on top again. And then maybe we'll get back to our regular experiments that I normally do. I just thought I'd start off a little differently tonight. Do something different. Try to switch things up a bit. Hope everyone's having a great day. Thank you there, lady. Uh-oh. Do I got the film? Yes, no, I don't think I do. Yeah, there's no film. I missed it. Let's try again. There's no film. No soap film. We'll try her again here. And then we'll get back to our normal scheduled experiments. Did I get it? No, I think I'm missing it somehow. Come on, man. There we go. Now I can see it. There it is. I got the film over the top. It's starting to grow. Thank you there, Reaper. Hello there, Willa Young. So for those who are just joining in, if I wet my finger, with the same soap that I use to make the film on top of the bubble, I can touch it. I can go ahead and touch this, and it won't pop. We ought to get a close-up. Maybe be able to see that. Can you see the rainbow on the bubble? I don't know if you can see it. Maybe you can see it from up here. It's slowing down a little bit because I think the water's getting a little bit cooler. Yeah, so it's not quite filling up quite as fast. Yeah, it's interesting. Good. That's good to hear, Luna, that you can actually see the rainbow. It's a little tough to see. Let me turn this light on and see if it works a little better. That makes it look a little warmer. No, it's not a toxic substance. I mean, okay, the carbon dioxide, so there's dry ice that I've placed inside this bucket. And the dry ice, I mean, yeah, if that's all you inhaled, that wouldn't be real good. You know. And it also is, I mean, carbon dioxide is not good for the body. That's why we exhale it, of course. It looks like I'm running out of dry ice, isn't it? Yep, you can tell. It's not bubbling quite as fast. You can see it down here. So let me add another piece of it. I doubt I'll be able to pop it through the bubble film. So I'll probably have to make another bubble film. But let's just put another piece of dry ice in. We get the bubbling going again. I'll probably pop that. But that should get us rolling. We'll see if we can get the big bubble going again. Potsify. I'm trying to make a big dry ice bubble. There we go. Nope, I missed. Try again. See if I get a film over there. Yep, I think I got the film. You can see it starting to grow. So is that, you know, the dry ice sublimes, it goes directly to the gas phase. Thank you there, Reaper. So as the dry ice sublimes, it goes directly to the gas phase. It also causes the water to form little tiny cloud droplets. So that's why the bubble looks cloudy. And yeah, of course, it's just going to fill the bubble, and we'll see what happens when it pops. Yes, the dry ice is very cold. It's like it's roughly the temperature of Antarctica on a bad day. The water, however, is very warm, and so it's causing the you know, the gas to form, and that's what's making the bubble. I'm going to blow on the bubble. Here we go. Watch this. You can see it shimmer. It's amazing it doesn't pop. I'm going to back it up just a bit so you can get a little more. I've not heard of the emo robot. Here, let's blow on it a little more. Isn't that remarkable? Just kind of shimmers there. Thank you there, YT Dapper Mouse. Woo, baby, that thing looked like it was going to pop. It's bouncing around so much. Yeah, I'll show you the dry ice. Sure thing. I apologize. I don't understand how to read that in Greek. I apologize. So here's the dry ice. That's what I've placed inside this bucket. So it goes directly from the solid phase to the gas phase. The reason why you're seeing this like cloudy stuff stream down is because it cools, you know, the surrounding air, and there's water in the surrounding air. And when the water hits, you know, it's gaseous water, and when it cools as it hits the gas that's coming off of the dry ice, it forms little liquid and solid droplets of water, and that's what gives you the, you know, the stream of what we would call steam, even though technically that's not steam. It's solid water, tiny particles, or liquid water, tiny particles. Sublimation, baby. You got it, Dr. Renard. Would it be possible to get the dry ice through the bubble without popping it? We can try it. I'm going to have to try to coat this with the same film that, I wonder if just the steam, you know what I'm using that term colloquially, you know, the solid ice particles and the solid tiny water particles cause that to pop. I'm not sure. I am not sure. How dry ice is made, you can take gaseous carbon dioxide, and you can make it expand into a low pressure region very quickly. I don't think I got a film here. Do I have it? I don't. I'll try it one more time. I don't think I've got a rapid enough production of gas, so I'm going to add another piece of dry ice. All right, here we go. So in it goes, another piece of dry ice. Pop it in. Try to get our film on. A little different experiment tonight than I normally do, but I like to change it up. I'm having trouble getting the film. Did I get it? No, I didn't. Come on, man. Let's get the film. I wonder why I'm having trouble. Here we go. Try again. There, I got it. Did I? No, I didn't. Nope. Interesting. I don't know why I'm having trouble, folks. There I think it's because there's like a little notch in the shirt that I have to avoid using. So I'm gonna try to make sure. Here it is. I got it. We got the film. We got the film. All right, I can get back. Sorry, when I'm doing that, I can't read the comments, so I apologize about that. The CO2 is pretty cold. Dry ice is solid carbon dioxide. Yeah, you can use CO2 in a fire extinguisher. Dry ice is indeed solid carbon dioxide, Rick. Thank you there, Legendary. I'm blowing on it right now to make it oscillate like that. Pretty remarkable how robust the bubble shell is. Hello there, Para. Pop it, says Roxana. Okay, this time my finger is not coated with the soapy film, and so when I touch it, it should pop. Next time I'll try touching it with my finger coated with the soapy film, and we can see the difference. So here we go. Let's get this going. Try to get this. See if I got that. Did I get the coat on? I didn't. Having a bit of trouble. I think I got it there. Yep, I did. So this time, notice last time, my finger was not coated with the soap film. This time, I'm going to coat it with the soapy film. There's a bunch of like soap in there. All right? So if I touch it now with my finger coated with the film, I can touch it and it won't pop. Isn't that cool? Whoop. What is the substance made of? Roxana, the stuff that you hear bubbling, that's dry ice. It's solid carbon dioxide. It is subliming, which means it directly goes to the gas phase. Here, I'll show you a piece of it. And then there's water in there. There's water in the bucket, as well as this stuff. This is solid carbon dioxide. You're welcome, Roxana. Surface tension is amazing, Renard. I know, man. I love the stuff. Hey, thanks there, Bazooka 101. Appreciate it. Stick my whole hand in there, says Charlie. Let's try it, all right? All right, I'm trying here. I'm trying to get my whole hand in there. So here we go. Ah, it's going to pop, though. Let's see if I can coat. Man, you guys are making me make a mess. Get my whole hand coated. All right. Let's see if it works. Ah, a little too much. I pushed it too far. I pushed it too far. It went there for a while, though. That was pretty cool. Yeah, the bubble did. Tell you, it will ultimately explode. So it has to do with, essentially when I coat my hand with the same substance as the film, it's as though I haven't really disturbed the film when I touch it, because it's the same substance all the way through. So, if my finger is coated with the same thing as the film, here, it's tough to see the film right now. You see it there? You see that film? Turn this light on. You can see it a little better then, yeah? You can see the light reflecting off it. So my finger's coated with it. I'm going to touch it. It's like it's not even being disturbed. Whoop. It's beautiful stuff. The Leidenfrost effect, silence. I have a video coming out on the Leidenfrost effect. It's either this weekend or the following weekend. Charlie, I'm going to maybe save. I think that's right, audio. I think you can do it with a glove. Does this work with any kind of bubble? Legendary, I would think it would. It looks delicious. I'm not eating it. How do I make it? Andres, I don't make the dry ice. I just pick it up at the store. I can buy it at a particular store around here. I'm not eating the ice, man. That's no good. That's going to harm me. I don't do that kind of stuff. Yeah, I'm not out to get views by hurting myself, people. I'm a little too old for that. I'm not going to eat Tide Pods or anything like that. That's just not, I'm a little too old for that kind of thing. Now, not over here in the States, you don't need it. You just I have to be, I think, like 21 to be able to buy it here in the States. And yeah, I'm plenty old enough. Can I pick it up? You mean, can I pick up the bubble? Yeah, I've got Dr. Renard. I'm not going to be doing my video with hot liquid metals, but I do a video on it with hot metals. No, I won't be doing that, YT. All right, let's do some other experiments with the dry ice. So that's enough of this. Let me set the other. Oh, look at that. Can you see that? I don't know if you can. Anyway, I'm going to go ahead and set the. Oh my goodness! I'm going to set the other experiment up. So bear with me a second. We're going to do a separate experiment with some dry ice. All right, I got to get it set up here. So bear with me. I'm going to make sure we get the camera all set up too. I'm going to get some stir bars here. All right, I'm going to pop these down. And I need to put the white background in place so it's going to look nice. Looks much nicer with this in place. What I'm going to try to do, you're going to see some colors. And so it's easier to see the colors with the white background. Let's get that in place. There we go. All right. I think we're going to start with this. Pop this in place right here. There we go. Get that spinning. And I'll get a little closer view. Okay. What the heck is this? Well, this is some water to which I have added universal indicator. And universal indicator is a system of dyes that changes color depending upon pH. So right now I see a red color, and this red color tells me that the pH is 3, so this is acidic. Now watch what happens when I start to add base, sodium hydroxide base to this. Dry ice is just solid carbon dioxide. That's all it is, audio trail. Yeah, don't eat dry ice. Here we go. I'm going to start adding some drops of base. And you notice that the color shifts to a blue, and down there at the bottom, it's even like a yellow or a green. And that's happening because the base is reacting with the acid, and it's neutralizing it. So you'll notice we started with a red color, and now we're up to like a pH of 6. So we've gone from a pH 3 to a pH of 6. The pH has risen, and we're closer to neutral. If I add enough base, this will turn green, which will mean that the acid has been completely neutralized. Of course, when I first drop the base in, it's going to look violet where the base is. Yeah, we got a little tornado going on here, just a little bit of one. So you can see. Maybe pH 5. That'd be cool, Chad. That's a great idea. As I continue to add the base, our pH should get close to 7. And what I like about this particular experiment is that you can just see some very interesting flow patterns that develop in the flask. The base is increasing the pH. The original acid audio was hydrochloric acid. It's the same acid that's found in your stomach. It's just that the acid that I'm using, that I'll be adding, is like 100 times more concentrated. There's some gloriously interesting, in my opinion, color changes that happen here. Dr. Renard, baby, I got some videos out where I put sodium in water. Fun times. Hydrochloric acid audio. Hydrochloric acid. Hope you're having a great day there, Tristan. So yeah, so now you can see as I've added an excess of base, we've shot past neutral. I mean, it's still a little bit neutral up here. It's actually pH of roughly 8. So we've shot past neutral. We're going to like pH 8, 9, and maybe even 10. What happens if you mix hydrochloric acid and dry ice? I'm thinking. I don't know. See, the reason why I'm confused a little bit is because hydrochloric acid and carbon dioxide are both acids. Last time there was a spider, Andres. It is some beautiful color combinations. Is blood acid or base? So MTF, blood is very slightly basic. So blood has a pH of 7.4. And if it varies too much from that, you die. That's right, Aldio. When a base is added, the pH increases. Hello there, Queen. Now, we're at a pH of 10, right? So very basic. I got to make a new chart here. I got a little bit of stuff on here. Anyway, I'm going to start adding acid to this system. We're going to watch the pH drop, all right? Someone's currently doing a chemistry test for a review. So in goes a drop, 2, 3 of acid. You might be able to see a faint red color starting to develop from the addition of the acid. Down here at the bottom, you can see the base has been neutralized, so it's a green color. And as that acid slowly mixes through the system, I won't be putting my finger in it. Indeed, Dr. Renard, blood indeed contains many buffers. So yeah, I've added enough acid to neutralize the base. Now I'm going to continue adding acid. And the pH should drop below 7. So legendary, a base is the chemical opposite of an acid. So an easy way, you can talk about acids more generally than this, but an easy way to think of an acid, it's a substance that donates H plus ions. So those are hydrogen atoms with a positive charge. Excuse me, an acid. I hope I didn't say base. An acid is a substance. That's what I'm adding, Kino. An acid is a substance that donates H plus ions. Those are hydrogen atoms with a +1 charge. A base is a substance that accepts those H plus ions. I won't be making any of that, Pedro. Sorry about that. I'm not a synthetic chemist. That is Kino. Kino has dropped in the chat the exact chemical reaction that is responsible for the color changes that we're seeing. Here, I'll drop it here as well. Sodium hydroxide, that's the base that I'm adding. It reacts with hydrochloric acid, and it forms water, which is neutral, and sodium chloride, which is neutral. So right now we have a slight excess of hydrochloric acid. I know that because the pH is slightly below neutral. And if I continue to add base, the pH will continue to drop, which means things will get more acidic. So I'm going to continue to add acid here. That's like 5 drops. Valeria, I am using a universal indicator, which is a mixture of 4 different indicators. Water can be both an acid or a base audio. It can act as either way. It just depends on what it's in the presence of. You mean bromothymol blue, Valeria? Bromothymol blue is a component of universal indicator. So there's 4 different indicators in universal indicator. They are thymol blue, methyl red, bromothymol blue, and phenolphthalein. All 4 of these added together give you universal indicator. The liquid, Mrs. Squid, or Mr. Squid, is just water with universal indicator added. Glowing, I have made nitrogen triiodide. Way back when I first started doing YouTube, I did a slow-mo video of nitrogen triiodide exploding. That's way back. Look at that, man. We got some rainbow going on. We got the rainbow action going on. That's when you're just seeing all the different pHs existing in the fluid at the same time. Moving inside the glass is that little magnet. Come on, Charlie. Thanks for the YouTube. They are pretty neat. Let's switch this one in. I wonder if this one's buffered or not. Let's see if this one's buffered. Let's pop this one on. This one's got a little slightly larger stir bar. I kind of think so, audio. I mean, it's like science and art at the same time. It's kind of fun in my opinion. So I'm going to see if this one's buffered. So I'm going to add a quick drop of base here. No, that pH is changing pretty quickly. So this is not a buffered system. Looks like Baja Blast. What we are going to do, now notice, I'm adding base to this system. So I'm increasing the pH. Okay. We're at like pH 9. And when it gets to violet, it's pH 10. Good old hydroxide ion, baby. Okay, now what I'm going to do is I'm going to turn this off. And we're going to add some carbon dioxide, some solid carbon dioxide. Okay? So here we go. In goes the solid carbon dioxide right here. I'm going to add this, and we're going to watch what happens. You know, we see the cloud. I'm used to seeing the cloud. And you might notice that I don't know if it's happening yet. I added quite a bit of base. You know, I don't think that's violet anymore. I think that might look a little bit more blue, maybe? Maybe? Maybe the pH has dropped from 10 to 9. And, you know, maybe it's looking like it's heading towards aqua now. So maybe the pH has dropped to 8. So we started here at pH 10. Now we're down to pH 8. And we're going to let that carbon dioxide continue to bubble through there. And you know what? It's looking green to me. How about you? So as the carbon dioxide bubbles through the mixture, it has changed the pH from 10 down to 7. And we may even get down to 6. So this is just a demonstration that carbon dioxide, when it bubbles into water, it makes an acid. Thank you there, Mr. Squid. Charlie, I don't have any pure nitrogen gas with me. Thank you there, emitter. Thank you there, abalone. Yeah, me too there, Dr. Renard. I don't... Fluorides, like sodium fluoride, doesn't bother me so much. Are the gases volatile? Chad, I'm not sure I understand the question, because I kind of would answer that as all gases are volatile. Emitter, actually, when carbon dioxide dissolves in water, it reacts with the water, and that reaction produces H plus ions, which can be donated, and that's why we call carbon dioxide an acid. What's up, DB Cooper? Frac plays, I'm sorry, I don't have any hydrogen peroxide. I can't help you with that. But I can add some, let's add some base to this. So in it goes up here at the top. You'll see it turn blue. But that carbon dioxide that's bubbling through, man, it just neutralizes that base like crazy. I'm going to add a bunch there. So that's a real big squirt of base. Let's see if the carbon dioxide that's in there is able to neutralize it. Yep, Valeria, the carbon dioxide is undergoing sublimation. Mass gaming, what's in this fluid mixture is water, universal indicator, which displays all these colors at different pH values. Like right now, it's like maybe yellowish green. So the pH is just below neutral. And there's some carbon dioxide, solid carbon dioxide. And as the carbon dioxide bubbles through the mixture, it makes the pH drop. So I'll go ahead and change the pH to high again by adding base, and you can see what happens as the CO2 bubbles through it. So in goes the base. The mixture turns blue. But that CO2 is going to just go ahead and neutralize that base. Carbon dioxide. Carbon monoxide is CO, as you note, audio. And that's some nasty stuff. You can't smell it. You can't taste it, but it kills you. It kills you quick. It's like a poisonous gas. Out of time, I don't think you'd want to drink this, because one of the dyes contained in universal indicator used to be the main ingredient in X-Lax. Trived gum, I don't have any sodium thiosulfate. I apologize. Mr. Squid, that's right. I don't have any hydrogen peroxide lying around. Actually, I do have some. I can see it right up there. I just don't, I don't know what it would do. It might oxidize the, it might potentially oxidize some of the dyes in universal indicator and make them go colorless. All right, I think I got one more experiment for you here before I do something else. Where did I put the flask? Where did I put those flasks? This one's fun. I like this experiment. Here, bear with me a second. Here, let's get another experiment going here so you can check something else out while I'm looking for stuff. Let's get this spinning here. Oh, this will be fun. Let's just leave it stopped. And then I'm going to add some base. This is fun to watch. Let's see what happens there. See if we get like maybe a little bit more base. All right, let's see what happens there. It's like nighttime attacking the day. So long, audio. All right, I'm going to go get a flask while we kind of watch what happens to those colors there as I've added base to the system. I don't know know what I did with those flasks I was going to use. Oh, here they are. Here they are. I found it. All right, I'll get this ready. Well, let's mix this up. We can do without the spam in there, Frack. Okay, I'm going to go ahead and mix this up. If there's more base than acid, then the violet will persist. If there's more acid than base, it'll look more red. And if there's equal amounts, they'll neutralize each other, and it'll be green. Here we go. Don't sweat it, Frack. Here we go. Let's mix it up. I'm guessing there's more base, and indeed there is. That's why there's a purple color. So I'm going to turn this off. Let's add a little bit of acid here. There we go. A couple drops. It's like the daybreak breaking through the night. It does, emitter. What precautions with nitric? Rocky, it depends on how concentrated the nitric is. Muhammad, I don't have any sulfur with me. I do not have any of that. Pretty. Okay, I'm going to mix this up, and we're going to see if there's more acid or base present. Here we go. Give it a mix. And that was gorgeous. What's it going to be? It looks like they neutralized each other. So the acid that was present at, roughly pH 3 and the base that was present, they were perfectly balanced, which is why we have a neutral solution. Pretty cool, huh? It did look like a flame. Let's do that one more time. That's kind of fun. So I think I'm going to do the darkness again. So we're going to add, 5 drops of base. Let's get that mixed in there. Oh, glowing. That sucks, man. All right. Turn that off. Let's add, 5 drops of acid. 1, 2, 3, 4, 5. See what happens. Glowing, what you can do to get that stain off your hands if you're making silver nitrate, you probably already know this if you've used silver nitrate. You just get some household ammonia, and you pour the ammonia on the stain portion, and that forms a silver ammonium complex that dissolves. And it'll just take that brown color right away. Pretty, huh? Very pretty. I'm going to let that set for a bit. Maybe I'll add one more drop of acid. I think it just needs a little more acid, just a bit. 1, 2 more drops. And then I'm going to set this up over here, okay? We got a secondary experiment that I'm going to do, that I want to show you. Actually, this flask doesn't look quite as pretty as I'd like. I'll use this other one. This one looks a little better, a little shinier, more pleasing to look at. I'm going to pop it on over here. Thanks, Reaper. Thanks for hanging out. Pigma Squatch, we're just doing experiments and talking about life and just enjoying the beauty of the science experiments that we see. Oh, all right, here we go. I'm going to add some water to this flask. That's probably enough. Get this going. All right. I don't have any lithium chloride here, Muhammad. I have some in my lab, however. Precautions for 50% concentrated nitric. I would make sure to use that in a hood. I would make sure that I had gloves on, goggles. I would have a lab coat on. I would make sure I had baking soda present in case I spilled it anywhere so I could neutralize it. Yeah, I'd be careful with that stuff. Look at that, folks. Isn't that gorgeous? All right, Muhammad. Isn't that beautiful? All right, over here, we're going to try something a little different. I want to get focused on it just a little more. I guess it doesn't matter. It's good enough. Okay. So what I'm going to do over here on this flask is I am going to add the universal indicator. Remember, universal indicator is also known as rainbow indicator. It displays these colors at different pH values. Yeah? It does look like a Van Gogh painting. I'm going to just put this. Okay. So I'm going to go ahead and add, that's purified water that I've added, by the way. Now, the flask wasn't clean, so I'm not 100% sure. JB, That's awesome to hear. So yeah, just to have them use some household ammonia and drop me a line how it worked. So yeah, I'm adding this universal indicator to pure water, and this is this bothers a lot of people to see it turn yellow. Let me explain. Add a little more. So I have added universal indicator to water that's been purified, and yet it's not pH 7 neutral, it's actually slightly acidic. And that's because any water that's been exposed to the air will have carbon dioxide dissolved in it. And I already showed in a previous experiment that carbon dioxide is an acid. So a little bit of carbon dioxide makes this just a little bit acidic, okay? No, it's just distilled. So this is just distilled water that I bought from the store, okay? All right. Now what I'm going to do is I'm going to add some milk of magnesia, which contains a base. This stuff neutralizes stomach acid, which is part of the reason why people take it sometimes. So I'm going to add some milk of magnesia, and we're going to watch what happens. Thoughts on fluorine, Nolan? I'm not real sure what you want me to talk about fluorine. It is the most electronegative atom on the periodic table. Here we go. Let's add that shot of... So you can see... Now you can see this stuff, it's like a white solid in a bunch of water. So that, it's cloudy because it doesn't dissolve, but a little bit dissolves, and the little bit that dissolves forms a base. And you can see our pH is now like, what's that? It's like pH 9. Stone, I don't know how to do that. Now it's pH 10. Yeah? So the magnesium hydroxide that dissolves. There's some magnesium hydroxide that dissolves, and that forms a little bit of base. So there's solid magnesium hydroxide in here. A little bit of this dissolves, and that forms hydroxide ion, which makes this basic. By the way, check this out over here. That's looking really pretty. Okay, now what I'm going to do... No, it doesn't contain any protein, Kyle. Now what I'm going to do, let me get this lighting just a little bit better so we can see it just a tad bit better. I hope that helps. Okay. I'm going to add hydrochloric acid to the magnesium hydroxide, and that'll neutralize it. So any of the hydroxide that's in here that's dissolved will be neutralized by the acid, and actually there's going to be an excess of acid at first. So there's your excess of acid, so it's going to look red. And now the acid will start to react with the undissolved magnesium hydroxide, the solid particles in there, and it'll bring the pH back up to neutral. And then as some of the solid continues to dissolve, that'll change your pH back to a high pH again. Thoughts on alkaline diets? Nolan, you can't change the pH of your body, and you wouldn't want to anyway. Uric acid is a nitrogenous oxidative metabolic product of purines present in nucleic acid. Can you please explain it to me? Heck no, Mass Gaming. I can't do that. Not without doing some reading. Sorry, I can't answer that off the top of my head. How do you make alkaline water? Yes, I've tested bottled alkaline waters to see. So basically, alkaline water is normal water to which they add a slight amount of a basic material like sodium bicarbonate, just a really tiny amount. And as soon as that tiny amount of alkaline material hits your stomach, it's immediately neutralized. So save your money. Save your money. Check this out over here. Yeah, I've done a blog post on it. This isn't peer reviewed, but I've done a blog post on alkaline water and whether it can change your body pH, and done a chemical analysis of it. You can Google, can alkaline water change your body pH? And ChemEdX, and that'll bring up the article. Here we go. I'm going to add a couple drops of the acid. So now it's acidic, and then as the solid magnesium hydroxide reacts and neutralizes that acid, it turns it green. And now as the solid magnesium hydroxide dissolves, it goes back to basic. Pretty cool, huh? Yeah, it is a pretty reaction. Yeah, chlorine that's added to water. So Nolan, the chlorine that's added to water is usually in the form of, let's see, HOCl. I think that's not hydrocyanic. I can't remember the name of the ion. hypochlorous acid. And then they adjust the pH to get the hypochlorite ion, and the hypochlorite ion is the thing that, you know, kills basically living things in the water. Yeah, the little tornado is cool. You got it, Dr. Renard. Keep fighting the good fight. Hey, let's check this out. That's beautiful, isn't it? Isn't that cool? Just kind of just letting that do its thing. So now we've got, you know, some of the magnesium hydroxide has dissolved over here and made this basic. I'm going to add a bunch of acid. And, of course, the pH is going to change, but there's still some solid magnesium hydroxide left. And that'll react with the acid and neutralize it. And then a little bit of the magnesium hydroxide that's left will dissolve. They sure would glowing, wouldn't they? That's the truth. Yeah, I agree, Morning. It's pretty, very pretty. So I've got a meeting that I actually have to go to kind of soon. And I'm gonna end the live here soon. So usually what I do at the end of the live is I flip the camera around and I just talk to folks. So if you don't want to see my ugly mug, now's a good time to get off of YouTube, all right? Or at least, you know, swipe away. Time for you to look at something else. Yep. Are we working strong against strong? Valeria, you know, maybe some chemists in the chat can help me out here. They tell me that magnesium hydroxide is a weak base. I'm not sure I buy that. I think it's a strong base, but it's considered weak because just a little bit of it dissolves. So if magnesium hydroxide is a strong base, then yes, I'm reacting strong with strong. Strong acid with the strong base magnesium hydroxide. Yeah, Muhammad, it depends on the source, right? There's some sources I see they call it a weak base. But I think it's strong. But, you know, just because I think it doesn't mean it's right. It's looking pretty, huh? So I'm going to stir this up over here on the left. If there's more acid present, it's going to remain orange, yellow, or red. If there's more base present, it'll be violet or blue. And if it's perfectly balanced, it will be green, neutral. Let's see. And it looks like there was more base present. Now, I have to store these. I've noticed that mold grows in all this stuff if it's basic. So I'm going to go ahead and add acid so I can just keep it here and run it again next time. I don't want any mold growing in that. And I'm going to keep adding acid here until I completely acidify the magnesium hydroxide. Let's flip this around. Let's chat a little bit. And then I got to take off. The red one's not yellow yet because I think all the magnesium hydroxide's been reacted away. I can tell that because it's no longer cloudy. Yeah, they could glowing. Absolutely. Thank you there, Valeria. I appreciate that. Let's flip this around. What's going on tonight? The acid I'm using, Pigma Squatch, is 20% by weight hydrochloric acid. That's what I use. How are folks doing tonight? Thanks for hanging out. Appreciate you enjoying, or at least, you know. Thanks there, Morning. I appreciate that. What's the other 80%? Water, Pigma Squatch. So, yeah, water. Hello there, Doug. Thank you there, Glowing. Yeah, I do lives maybe once or twice a week. Usually I'll do them. I am a teacher. I do the lives like Friday evening sometimes, or like weekends. All right, Mr. Skinner. Hey, today in the United States, it is Veterans Day. So drop an American flag in the chat to thank our veterans. And if you happen to be a veteran, just drop in the chat what branch of the service that you served in, if you feel comfortable, if you feel comfortable doing so. Dark light, I usually stream like Friday or Saturday, or usually around this time. Thank you there, Glowing Ghoul. Do I know how alcohol percentages are calculated? They can be calculated in a lot of different ways. So by volume, as you suggest, which just means like 14% by volume would be, you measure out 14 mils of the alcohol, you measure out, what would it be, 86 mils of water, and you mix them together. That's going to be 14% by volume alcohol. Hey, let's keep the politics out of here. If you don't mind, Daniel. I don't want to say one way or the other, but I'd rather just keep things. This is a place to just enjoy and forget what's going on in the world. Thank you, Dr. Renard. I appreciate your service. Yeah. So yeah, please, hey, if you want to go look at politics, there's plenty of places to go on YouTube to do that. But I come here to my channel, and doing these kinds of things is a way for me to experience the beauty of the world. Yeah. Thank you there, Emitter. Thank you that, Valeria. Yeah, just let me know how you're doing. Let me know if you got any science questions. If I happen to know the answer, I'll do my best to answer. And if not, I'll certainly tell you. Man, science is very broad. There's a lot I don't know about it. Thank you, Mountain Goat, for your service. Appreciate that. Mountain Goat in the Army. Yep. Thank you there, Dr. Renard. Is the red yellow yet? Let's turn it around. It is not. So I don't think so, because you can tell if there's magnesium hydroxide left, it'll look kind of cloudy. So there'll be some solid left. I've reacted away all the solid. Thank you for your service, Doug. Sure, Silver Scorpion. What would you suggest we use in place of beauty? Gorgeousness? Awesomeness? Awe? Gives me butterfly feelings in my stomach? I don't know. Yeah, give me some synonyms for beauty. Stunning, I like it. The stunning nature of the universe. Visual appeal, sure. Visual appeal. Appealing. Hope you're having a good day too, Tristan. Well, I better go get ready for my meeting. And then bed. So, hey, thanks for hanging out and for viewing some of the... Thanks there, Mr. Skinner, for viewing some of the awesomeness that exists in... All right. I appreciate it. And we'll... Yeah, thanks for hanging out with me, everybody. I appreciate it. I guess I gotta go to work. So, yeah, thanks for letting me view some of the visual appeal of the universe.